We managed to make it, though. We've got a 2020 Dorkbot. It's happening. Despite the weird things that are happening at the beginning, it is on and popping.
And next year will be 100th Dorkbot. It will also be 20 years since the very first Dorkbot London. So the next Dorkbot will be potentially the biggest one ever. Hopefully we will do that in person, because I cannot tell you how many problems we've had with video streaming in the last 24 hours. So I am looking forward to it. We have 3 speakers lined up for you tonight, and potentially a performer as well, but we're not quite sure yet because it's Dorkbot. We don't know whether it's going to happen. Up first, we have Alex, and Evan's going to give a little introduction to him. Throughout this, we're going to be taking questions from the audience. I don't know, can we see on, here we go, on screen we have a website you can go to. It's also linked underneath the video. You can go there and submit questions for the speaker or questions for us, and there's the Slack as well. Come and chat to everyone there. Any questions you submit will be asked by Evan and I after the speakers have been on. Evan, take it away.
Yeah, and I can see I have the Slack to my side. I am paying attention to you all. I just want to be clear about that. I'm browsing the Slack on the side. It's flying by. Hi, everybody. It's great to see so many familiar faces there. I wish we were kind of all in the same space where you could just shout at me instead of texting across Slack. But anyway, let me introduce Alex. So Alex is a longtime Dorkbotter. I would say he's a geodesic dome aficionado, and I'm always a fan of the stuff Alex has. I know recently he was nice enough to send me a whole bunch of stuff on kinetic art, and I think that's in line with what we're going to see today. It's about Senster, and Alex tells me, well, it's been 15 years since the original 2005 Dorkbot presentation of Senster. So take it away, Alex.
Hi, everyone. Good to see lots of you familiar faces. So yeah, as Evan says, the first time I talked about the Senster was 15 years ago at Dorkbot, but my interest goes back even further than that, actually, and it stems from about 1985 when I was 15, so give away my age. I had a cold, I think, and my mum bought me a book, because she always got me a book when I was feeling ill, and she got me this wonderful 80s book about robots. And amongst the lots of fantastic 80s illustrations and things was a tiny picture in one corner, and I'm going to come back to that picture in a moment, because that picture and that sort of little caption beneath it basically has played quite a large part in my interest in the last 20 years, which is kind of funny when you think about what influences your life. So, is it presenting my PowerPoint? Yeah, good. So, this is the picture in the book I just showed you, and the caption just said, "The hydraulically operated Senster reacts to the sounds and movements made by onlookers, giving the impression of being alive." And it's that impression of being alive that really got my interest. Somehow really captured my interest, but I couldn't find any more information. There was no more information about it in the text. Days before the web, you couldn't look it up. I couldn't find any books about it. So it stayed there at the back of my mind as being kind of an interesting thing. And then years later, I was doing a PhD at Imperial. This was the late 90s, 96 onwards, on medical robotics. And the web had come in, websites were going up, and I thought I ought to do a website. So I did one on the Senster, on the bit of information I managed to glean along the way. And I was doing that one day, and my supervisor crept up on me, looked over my shoulder and said, "Alex, you're not doing work, are you?" And I was like, "No," got caught out. And he looked at what I was writing and said, "Oh, that's Edward Ignatovic. I was good friends with him. We worked together at UCL." So one of those coincidences, but I managed to get hold of Edward's widow, and there's a whole story about getting hold of some of his papers and what he did and so on. He died by that time, unfortunately. He died in 1986, so I never met him. But I realise I've only got 20 minutes, so I better head on through. He was born in Poland in 1926, left at the beginning of the war, eventually, in a very roundabout way, managed to end up in Britain, studied art and but was very interested in filmmaking and photography and lots of things, including this quote I found of his, which I think makes him an honorary, if posthumous, Dorkbotter. Funny thing, at the Ruskin, I was very interested in electronics, built myself an oscilloscope from bits of an old radar set. So this was just after the Second World War, where you could get hold of a really interesting government surplus kit. But at some point, feeling introspective and conscientious, I said, I've got to concentrate on my drawing and painting, throw away all that electronics, dedicate myself to art. Stupidest thing I've ever done. So he really regretted it later. He had to start from scratch again. But you can see, even from the early part of his life, he was interested in electronics. Worked for a bit as a furniture designer, builder, but age 36, he left all of that, left home, and went to live in an unconverted garage in North London, and he returned to making art. And this is a photo of that garage. So that's one wall. In the middle, there was a fireplace, and he slept on a cot. And other than that, there was no heating or anything like that. But I think, again, this is a wonderful Dorkbotting type workshop. So you've got a lathe down there in the right-hand corner, Myford 7, classic model engineer's lathe. In the middle, you've got a hydraulic power pack. On the left, you've got an oscilloscope and various other electronic bits. But on the top shelf, you've got life drawing, life sculpture. And indeed, the white bust on the very left is his is a woman called Olga, who he married and who is still alive, although very frail now, and a very lovely lady. So I'm going to zoom through this. His first work that kind of we'd be interested in as Dorkbots, I think, really, is Sam, a beautiful thing of aluminium vertebrae, fiberglass parabolic reflectors onto 4 microphones. And if I play a video clip, it was exhibited at Cybernetic Serendipity, which was the classic, for one of the first kind of computer art shows in 1968 at the ICA, Institute Contemporary Art. And this thing stood on a podium, and the 4 microphones detected the direction of sound and made it turn to face the people making the sound. Now, the great thing here is it wasn't just reactive in the sense that it was only sensitive to particular ways of making sound. So if you shouted or clapped at it, it wouldn't turn. It had to get kind of sort of a constant level of kind of mild sound. So if you talked to it in a kind of conversational way, it would turn and face you. If you shouted or clapped, it kind of wouldn't react properly. So it had an influence on the people in front of it. As well as responding to what they were doing, which is really kind of interesting and feeds through to the Sensor. But I don't really have time to go into the SAM too much today, but I'll move on. But a lovely piece of work, still around, not working, unfortunately, but currently it's on tour with the Science Museum's Robots exhibition, which was in London a couple of years ago and is now touring the world. So I believe it's in Hong Kong at the moment, with this video clip playing and behind it. So I've got some drawings of what's going on inside. The electronics running it, no computer involved, pure analog electronics. Which leads me on to the Sensor, 1970. So this is 50 years ago this year, actually. As I understand it, as I believe, it's the first sculpture controlled by a computer, as far as I know, in the world. And I'd love it if somebody could tell me the contrary. We can discuss that if you know. But this was about 2.4 meters tall at the shoulder, at that sort of shoulder end of it, about 5 meters long, that arm sticking out, the head, all made out of welded steel, made by the welder at University College London called Stan the Welder. I haven't been able to find his surname. 6 joints and 2 in the head, all hydraulic. And the hydraulic power pack was in the basement of the place. So there was no motor noise, no robotic kind of sounds. It was very silent. You just heard a whoosh as the head went past. So it was really nice. Microphone array in the head, radar motion detectors to detect movement. So if we play the video clip, it was on display at the Evoluon Center in Eindhoven as part of, and the Evoluon was Philips, the corporation, its big kind of future technology showcase. A beautiful UFO-shaped building with lots of displays in it. And this was the sensor there. As you can see, the microphones in the head are turning to face the direction of sound. So you can see people slapping the wall of the enclosure. That makes a sound, and the head's turning to face that. And it's being attracted to the sound. And if the sound continues long enough, the arm turns to follow the sound. That's Olga, by the way, clapping. And she's still around with us, just about. The two horns on the side of the head are Doppler radar detectors, and they're attracted to the direction of small movements, but repelled by large movements. So it was kind of attracted and repulsed, scared, or attracted to people. And it was incredibly popular. It was people tell me it was the most popular thing on show. People would come miles to see it. They'd have their wedding photos taken in front of it, which I think is fantastic. And you can see it's got this beautiful movement, very smooth, very kind of animal-like, without it pretending to be an animal, which I think is really important. It's not animatronics. That's the computer. All computers should look like that. Flashing lights. That's what computers should be, not our modern-day boring things. So a little pan across the arm, and you can see it's all hydraulics with the head there moving to face the sound. And you can see some of those moldings behind are classic Ignatovic moldings. He would make the patterns in wood and cast it in his garage in a sort of aluminium casting next to his cot where he slept. And it has this wonderful kind of seeking behavior as it looked around for sounds around. So a lovely, lovely piece of work. 50 years old, remember. You can probably tell from the fashions there. And that's Edward at the computer programming it in Eindhoven with Olga sat behind him and the sensor in its enclosure behind. So the computer system for you people interested in that, Philips copy of a Honeywell 416, 8K of memory, so 8 kilobits, not bytes, that's bits memory, so tiny amount of memory, way less powerful than the the Arduino, modern students are used to. All on punched paper tape, of course, to load the program. Software listings still in existence. There's the computer without it being put in those cabinets. So our computer should be none of these screens getting in the way, no video streaming on this. It's all punch tape and teletype and all that kind of stuff. There he is programming in front of the electronics. There's the software listing, of course, assembly code. I chose the page with the most comments there on the right hand side. Of course, the rest of it has barely any comments at all. So trying to work out what on earth's going on is tricky. But of course, having a website about the sensor, I got an enthusiast about the Honeywell 416 contact me, and we sat down and went through what the program does, which was great. It's great having geeks of old technology. There's a close-up of the system. Most of the circuit, so it used a digital computer, but had a lot of analog stuff as well, and used circuits like this to make the movement really smooth. And this is one of the key things about the sensor. Why is it such an engaging thing? One of the reasons is it moves in a lovely way. It's not it's not robotic in that sort of classical robotic way of moving. It used that circuit there. It's a low pass filter, basically, for those of you in the know, and it smooths the step change in the joint position commands. So rather than move linearly between each step, you got this nice smooth curve in position. And you could change the speed by which it moved, so you got these different curves. So you can move quite fast, but take a longer period. But it was always this smooth motion. Now, I did a bit of research into this. When I found that circuit, I simulated it and got those outputs. That's where those graphs are from. And I found this paper written in 1985, 15 years after the sensor, about looking at how human arms move when we're reaching up in this kind of motion. And if you plot the graph of the position move in the joint, and then you look at the velocity of that, this is the kind of graph you get. You get a bell-shaped curve, bit asymmetric, so it moves very quickly to maximum speed and then slows down as it reaches the target point. So that's human movement. So that's that graph on the right. That's human movement on the right. On the left is the output from that electronic circuit I showed you a few slides ago. That's the way the sensor moved. So the sensor moved in similar way to human movement, and I think this is one of the reasons why it's so attractive to us. It's this lovely, smooth, flowing movement. The sensor was dismantled around 1973, and some of it was junked, some of it was given to local enthusiasts, but the main part of it went to an engineering company in the Netherlands, where it got put on these concrete blocks in its car park, and it stood there for many, many years. And I used to give this talk, and I used to finish on that slide as saying, you know, that's the sensor as it is now. It's died, it's not moving, you know, brings a tear to your eye. But we have good news, because 2 years ago, a team led by Anna Olszewska at AGH in Krakow managed to acquire the sensor. Went to the to Netherlands, took the sensor back to Krakow, and AGH is a big technical university. They've got great facilities. I went and visited, a good sort of robotics section, people who knew about hydraulics, and they've managed to resurrect the sensor, which is fantastic news. They unveiled it in October 2018 and invited me along to see it. And I have to say, as soon as I walked into this room, I walked up and touched it and burst out crying, which was really I was kind of a bit surprised with myself. But I've talked about the sensor so many times over so many years. To actually see it for the first time was really quite a thing. Also, there was Edward's family. That's Richard Ignatovic on the right-hand side, his son, and his daughters and his wife there. And they were a lovely bunch, and we had a great time being hosted by AGH. So all that electronics and the big computer I showed some slides ago has now been replaced by this, which is a modern PLC, programmable logic controller, as used in industry. So much more compact and kind of easier to get going. The amazing thing is oops, let me just turn the sound. The physical part of the robot was almost ready to run after what, 40 years sat in a field. Even some of the hydraulic valves ran straight off. The amazing thing, I think, is some of the hydraulic valves are also the exact same part number is available now, 50 years ago, after this was built. Because although the electronics has miniaturized and all of that's got much better, things like hydraulics is surprisingly little development since that time. The valves are exactly the same model, plug-in replacement for the original ones. The head was missing, unfortunately, so they made their own and implemented some sound following in there. And in the meantime, since I got there, because my website, I knew the person who has the head. He'd visited the sensor and found the head lying in the grass and took it. but he's now sent it to AGH, and they're going to sort of incorporate it into the original body, which I think is great. So I realise I'm on 18 minutes, so a couple of minutes more and then I'll finish. So December last year, I visited Olga with Nick Lambert and Richard, and we decided it was time to kind of sort out the archive, his archive. And we packed away most of it in boxes. There's lots of stuff there. Olga fantastically had kept everything. In fact, the first time I contacted her, about 20 years ago, she invited me round, and I got there, showed me this cupboard full of papers and things, and said, go ahead, have a look through. I'm going shopping. So she left me in her house, just going through papers for hours, and I was there for hours. I don't have time to talk about all the other things he did. He did another great robot called the Bandit. Don't really have time to talk about it. He did some great early computer graphics, amazing stuff. But we gathered all of this in boxes and hired a van, and we drove it into storage. And then I was going to start sorting through it and archiving it properly. And then 5 days later, I went into hospital and ended up having a heart bypass operation. So exactly a year ago, I was lying in hospital recovering from having my chest cut open and all of that, and then got out of hospital, and then of course COVID hit, and that's all still in storage at the moment. I've not been able to touch it, and I really look forward to going back to it, because my plan is to scan everything, digitize it properly, put it all online as a proper archive that researchers can use, that we can supply images if people want to run exhibitions and so on. But my big aim for this really is, once we've done all of that, is to set up an exhibition of his work. We have so many artifacts, so many documents, we can really tell the story really well. And the great thing is, Anna at AGH is very happy for the Sensor to go traveling. So the thought of having Sensor over here and on display and people interacting with it is really, really exciting, and I'm really looking forward to that, and I really hope we can manage that once all this COVID stuff is done with. I have a website called sensor.com. I was complimented on its retro feel. It's not retro, it's just original. I basically haven't touched it since the year 2000, partly because I've got loads of things to put on it, and I've always been a bit daunted by the effort needed to do it, but I will get around to doing it sometime. If you want to see a longer version of this talk, I gave a talk to the Computer Art Society a few months ago on Zoom, and we recorded it, so it's available on YouTube. That's about an hour long, so it's about 3 times as long as this. So I go into rather more detail in that, but please feel free to look that up. And I'm more than happy to, if you're teaching at a university, to come and talk to your students, and because I'm a strong believer in people knowing the history of their subject. And if you're working in this kind of area, that creative technology and those kinds of things, I think we should really know what was done before. 50 years ago, this was amazing. If it was on display today in London, it would still be amazing. And that's a 50-year gap in a sort of technological area. And I really think, if not, Edward would be a proper Dorkbot. He was an artist, a sculptor, electronics, computer programming. Nothing would stop him doing what his, achieving his vision of what he wanted to express in his art. So that is me. Sorry, it's a bit rushed, but I wanted to cram things into 20 minutes. So there you go. That is me.
Can we clap? that was amazing, Alex. Wow.
Yeah, there was a lot of feedback there from all of the communication channels. Everyone loved that talk. So
I've not been able to look at that while talking. So
well, you will now. So we've got a few questions from the audience.
Yes,
quite a few, in fact. So the first question is from Ben. How would you evolve or reimagine the Sensor for the 2020s?
There are some people working in similar areas. I went to an online talk just last week, and I'm terrible with names, so I've completely forgotten what it was called. But there are people working on it now, particularly with industrial robots. There was an installation at the Design Museum a couple of years ago, which I've kind of forgotten, unfortunately, because I'm terrible with names. But I think, now the computing side of things is really easy. The sensor side of things is easier. I mean, he liked using sound direction, but actually it was really hard to get working because noisy environments are just a nightmare to try and localize. But the people I talked to said, well, that's actually what gave it quite a bit of its charm, because if it had been 100% perfect, it would have been a lot less interesting, because you've got that kind of randomness in its behavior. I think he never made any claims to it being alive or AI or anything like that kind of thing. He always said it's purely reactive. Any kind of impression of intelligence or character or anything is purely us projecting onto it. And it's one of the things I've thought about a lot over the years. Is I'm really reluctant about I've done lots of work in robotics, and I hate it when robots are pretending to be intelligent or pretending to have conversations with people, and it kind of winds me up quite a bit. Shouldn't say it publicly, maybe. Our university has one of these Pepper robots, the humanoid robots. And it went to Parliament a year or two ago and gave evidence in front of a select committee. And one of my students had spent hours programming in the speech and the arm movements, and I hated it. I would have nothing to do with it, to the point where my colleagues and I just wouldn't do anything with it. Our head of department had to take it to Parliament instead.
That's perfect for Parliament, though. I feel like that's, they probably raised the intelligence a bit.
Yeah, it might have done, yeah. And the university loved it because it's publicity and all the rest, and I hated it because it's faking. It's not got that intelligence. And if you think, if you're telling the public it does, I saw the sort of people Twitter feed saying that's not real. Somebody sending it, instructions. And it's like, yeah, of course it is. The fact that you think it might be real is really worrying.
But was there any, there's a lot of early cyberneticists had this sort of claim to some deeper understanding, right? Like De Beer had his fish tank, which he thought had more intelligence than a corporate board. And there was, I forgot the guy with the tortoise, right? So he was,
Gray.
He wasn't in the same league though, right? Mm-hmm.
No, I don't think he made great claims for cybernetics that way. For him, really, he was an artist, and all of this was making things that communicated what he wanted. I mean, his son Richard told me that a lot of it came down to visiting the zoo and walking into an enclosure, and the lion was lying down, and its head just looked up and kind of followed him across as he walked past. And he thought, as a sculptor, wouldn't it be great if you walked into an art gallery and the sculpture itself just sort of followed you around? And he wasn't claiming anything more than that, or anything, grand kind of academic thoughts about it. He just wanted that kind of connection with a sculpture. And
Okay, let's jump to a couple more questions.
Modern interpretations. There's loads you can do with. I've tried things with camera tracking of people. There's loads of programs out there that, of course, from OpenCV to the more modern sort of machine learning type approaches and that kind of thing. But there's something about the sensor I really like that I haven't really seen yet in modern versions. Yeah.
Well, should we jump to Dan's question, do you think?
Well, I was actually just going to answer the first question, which is from multiple people. Will the video be available? Because they love this talk so much. Yes, the video will be available, assuming that you don't ask us to take it down. So it's, we'll have that. And then we have quite a few other questions. So one from Dan Stowe, which was how and why did the motion curve match human movement? Do you think that was carefully done, or did you think it just happened?
So I looked around and that I couldn't find anything in contemporary publications that showed that curve. And as I said, that paper was like 15 years afterwards. My understanding from anecdotes was basically he sat down with an engineer from Philips, and they basically tweaked the that circuit until it produced the movement he was happy with. So it's very much down to his artistic, aesthetic decision on what it should move like, rather than trying to copy a biological model. And then the interesting question becomes then is, did he choose it because it looked like a natural movement from a human being or an animal, or is it attractive because it looks like natural movement? Is there something intrinsic in that movement that we like? All those kinds of questions. There's loads of interesting questions about, the vision part of our brain that handles movement moves very fast, because our evolutionary brain, you have to decide very quickly if something moving is after you to kill you, or you could chase it and eat it. So the back of our brain kind of decides if something is animal moving or just the tree blowing in the wind. So there's something deep in our brains that looks at the movement and goes, that's a living thing. And then you look at it again and go, well, it's made out of metal. That's not living. So what's going on in your brain when it's doing that? And, the discussions, like, it has this nice kind of, it's almost like, I don't know, an elephant or a giraffe in the zoo kind of looking around. If it could track you and, follow you around, like keeping perfect track of you, it'll be far more scary. It'll be like a predator rather than this kind of giant sort of herbivore just kind of looking around who's coming. So, what is it about the movement that makes it non-threatening as well? Kids loved it. And this huge metal thing should be scary, but it's not. Why,
So I think we probably have time for one more question. Just a quick apology to everyone who's either tuning in or still tuned in. We've just had the stream go offline again, apparently. It wouldn't be Dorkbot without technical problems. I think this is part of the performance, frankly. So deal with it. The final question we'll go with is from Aisha, which is, what are the problems with the magnetic tape, and do you have solutions?
Oh, no, it wasn't magnetic. It was paper tape. It's
even better.
Paper tape.
Paper tape. Yeah. Well, I'm so old that my first year at university, we did experiments in data rates by running paper tape through the teletype, and it's literally paper tape about I can't get my head around this mirroring. It's a paper tape about that wide with a series of holes in it. Was it? Oh, I'm sure Dorkboxers would correct me if I get it wrong. It's got it's basically bytes encoding in a line, and you just have a long strip of tape that you run through the machine to load the program. So no magnetic memory or anything like that. And that's the great thing, actually. The code listing is on paper. If it had been on anything else, we wouldn't be able to get it. It was, again, when I went to university, we had to output all our code on these reams and reams of the concertina fold paper, and we had to hand that in as our assessment. And these things survive much better than magnetic tape, long since.
So I have a follow-up from Aisha who says, no, one of your slides about making an archive referenced magnetic tape.
Oh, that's from his later work. That's from his work in the 80s, sorry. So he went, he did lots of paintings and things, computer graphics, and that stuff's on magnetic tape. And that's a real problem because I don't know what format it's in. But I've talked to some people who do have ancient machines who can read this, which is great. And we'll run it through and see what we can get back from them. But actually, there are some cine films which have also survived really well in that archive. I couldn't go through it all. But, the great thing is you take them out of the archive, you hold it up to the light and you go, that's the Zenster. Wow, that's a bit I've never seen before, And that's what's really annoying at the moment. That's in boxes currently at the back of somebody's office at the Birkbeck College, where we stored it for a few days. That ended up being a year ago. So I'm really excited to get back into it, but we can't get in because of COVID, of course.
No.
So, yeah, very exciting. So, watch this space. In a couple of years, in a year or two's time, hopefully, we should have lots more to show.
Oh, brilliant.
Excellent.
Well, looking forward to that.
Yeah, so I think it's probably time to go on to our next speaker, who is Julie. I'm hoping that Julie is ready, given we're having so many stream disasters and things. It seems likely that something else will go wrong now. But Julie Freeman is going to be talking about her attempts to convert urine into power and microbes in virtual environments and all sorts of things, which honestly I don't entirely understand yet, so I'm hoping Julie's going to explain. So Julie, I believe it's over to you.
It is over to me, and I'm not sure this is such a... Can't share my screen. Hold on. Here we go. Such a cobbled together presentation that I hope is going to make sense to everybody. But following Alex feels like a massively tough ask. So I wanted to talk about a project that is still in progress, and I'm excited about it because it feels like a piece of artwork that is working with scientists that is really a kind of brilliant exploration of how artists and scientists can work together to sort of achieve a bigger aim. And so I called the talk "Why We Should All Be Taking the Piss to Save the Planet," because essentially a project that is completely fueled by human urine. And the project's called Active Living Infrastructure Controlled Environment, ALICE. Academics are really good at coming up with these kind of like acronyms for things. And it's an EU project, a collaboration of Newcastle University, Professor Rachel Armstrong, who is amazing. She's the lead of the project. And then at the University of West of England, in the Bristol Robotics department, is Yanis. And they've worked together previously, and also the rest of the team. They worked together previously on a project called Living Architecture. And their premise, what they were trying to work with, was this idea that what would it be like to embed microbial fuel cells into people's houses so that they could generate electricity from our waste water, from waste urine. So the Living Architecture project preceded ALICE, and they built this wall, and inside the wall are these microbial fuel cells that this project took urine, and it took also kind of synthetic material and then output different things. But we're working with actual human urine. So to step back a bit, like, what is a microbial fuel cell? It's essentially a battery that contains fluid, and in one side, in one cavity, it's got different bacterias that they generally get from kind of sludge from waste plants, and it's fed. There's a sort of matrix in between, and it's fed with urine. And then the way that as the bacteria break down the organic waste in the urine that they need, which is effectively their food, they excrete electroactive byproducts. And then the electrons from these byproducts travel from the anode chamber to the cathode through the electrical circuit, and then they produce power, which is essentially just a battery. So they're really clever, these microbial fuel cells. And one of the amazing things about them is that they can be dormant. So if they don't get any food, essentially, if no one pisses on them, then they can just wait. And then when they get their food again, they reactivate. So with the this project, they've, as a sort of case study, they took these fuel cells out to places like Kenya and Uganda, and they installed them as part of toilets that are outside girls' schools. One of the problems in those two areas is that when the young women go to the toilet, especially around the time of their period or anything like that, they need to use the toilet, but there's no light out there. So often they were subjected to being sexually assaulted. And so it's a real problem, just simply going to the toilet in some of these small villages. So they installed these huts that had the microbial fuel cell walls built into them, and it meant that as much as the toilet was used, that there was always light, and it had this kind of secondary effect of not only providing a toilet for people to use, but also to reduce the sort of predatory nature of people that are hanging around by those toilets. So it's a really powerful piece of technology, and it's really something that can and should be part of a sustainable future in terms of electricity. So when Yanis and Rachel came to me, and we were talking about how we could create an artwork that would help kind of convey the electricity that was produced by these cells, and if we could make something that would be engaging and fun to play with, to try and get people to think about microbes as something that were friendly and clean, as opposed to something that should be avoided. And so one of the interesting thought experiments we did was to compare data and microbes. So I've done a lot of work over the last years with data and considering data as an art material. So in this sense, we were thinking, well, if microbes were an art material and data is an art material, where are the moments that they come together? And so we came up with a whole list of things that are actually quite similar. They move in different ways. Data does that, microbes do that. They feed off different things. They can be benign or malicious. They can be cultivated. They're not always easy to understand. It works well en masse. They're not very good at single points or single bacteria, single microbes. And they've got a lot of power. And this idea of power of data, we've seen how all powerful data can be, even if it's misrepresented. And then microbes, these microbes are also powerful because they're literally generating electricity. So there's many differences, but the key difference is that one is perceived as clean, so data, and then the other one is perceived as dirty. So the project was about trying to kind of mix that up and reposition the idea of what microbes are. So we came up with the idea of data microbes, this concept of data as microbe. And it made sense to me. Some of my early computer programming, what inspired me to get into this whole field of computer art, data art, was that I started learning C programming, and I made artificial life programs, and I could witness these animations that would have this amazing emergent behavior. And so for this project, it made sense to go back to my roots and think about artificial life-based system and how I could use data from real life to inform the artificial life rules. So this kind of linked to this idea of what Rachel and Yanis call a microbial consortia, because it's not just one microbe in the fuel cells, it's like a whole variety of different ones. And then we can look at that in the same context, look at that in the same way as we think about a data consortia. All the different data species match with all the different microbial species. And each species has their own properties. So they have power, flow, temperature, and so on. So we started working on a framework that would allow us to take the data from the MFC setup and turn it into something that would be navigable and interesting. And we called it the data bioreactor. Essentially, it's just a basic computing system of input. Something happens in the middle in the ecosystem, and then there's an output. One of the things that we set up was that we wanted the whole system, if possible, to be completely powered by the microbes. So obviously, the microbial fuel cells the number we've got don't give enough power to even power a computer or a screen or anything like that, but it can power a little onboard computer that is then hooked up to a bunch of sensors that are monitoring the system. So the actual data acquisition is powered by the microbes themselves, and then that's sent out to a server, which is where we pick it up, and then the rest of it is powered kind of normally. And to be able to do this, I found this book, this natural computing algorithms book, and then just got completely obsessed by it. And then you can probably find a version online, or you'll be able to get it from a library or something. But it's got just a whole series of algorithms that are based on natural systems. And we used one that was called bacterial foraging optimization algorithm with this additional social communication, so we could see what things are doing. And what we tried to work out was how we could build this system and then have data feed into it from the microbes. And this is the kind of structure of how it works. So what is coming into the system? Which bits are we interested in most? What's going to happen within the system? How do we convert the data into something that is kind of interesting? How do we then output it so that it makes some kind of art experience? So one of the things that happened during the pandemic, we've been working on this for quite some time, and we developed it as a physical structure. So one of the things that the Bristol Robotics Labs have been doing is having a series of urinals at Glastonbury Festival, and then when the festival goers were going into the toilets, they could charge their mobile phone, and it's called P-Power, that project. So they go in, charge your phone just by donating your urine. And we like that idea, but we were like, well, let's build it into something that looks a little bit more attractive. Let's make an art installation. So we were going to, before the pandemic hit, we designed a whole physical structure, this kind of like tower device. And then the way that you would view the animation would be through a sort of augmented reality on your device or on your tablet, whatever you had. All of that work that went into that got panned because there was no Glastonbury, there's no New Scientist Live. So everything had to be completely reformulated to being online. I'm not going to talk about the sound because we haven't done the sound yet. That's next year. So to inform the animation, we wanted to look at not just the bacteria and how they're moving and looking at the data fluctuations. We wanted to look at some kind of way of holding it all together. So these are close-up microscope images from the matrix that the bacteria that land on, and then they create the biofilm whilst they're ingesting the urine. So this is kind of like the debris that gets left behind. And when I show you the animation, you'll see that the matrix is kind of like a fundamental aspect that holds it together. And these are some early ideas of microbes anyway. So I'm going to stop talking. I feel a bit disconnected because I can't see the teams. Right, we're back. So Alfie, can you flip to the live version that you've got? So this is it is still a work in progress. So we're still developing. We've still got a little bit more work to do on it. But this is where we ended up with. This is the data bioreactor. And what you're looking at here is a series. There's 5 species of data microbes, and they've all got kind of these different properties. And some of them are more transparent than others. What we wanted to do was kind of create things that you had to look at a little bit more closely to see what they were doing, rather than having something that was kind of like obvious and very contrasty. So you can see the matrix I referred to in the background, and what the all the microbes are able to either stick to the matrix, they have this kind of attraction to the matrix, or they free float around. And so we built into this an interface so that you could start playing around with what you can see. So Alfie, if you can switch on go to the layers menu and switch on you can switch off the matrix. Sorry, I lost the screen. And the idea behind switching on and off the matrix is simply so that you can get a kind of negative impression of where the microbes are colonizing and where they're not, and you begin to build up a picture. And then also, if you want to look at them, often when scientists are looking at microbes, they use different stains to show up further. So we looked at the different types of stains used, whether they were fluorescent proteins or whether they were kind of like a basic, just a normal color stain that shows up in normal light. And so this is the fluorescent one. The other ones are rose Bengal and Deerful, so you can watch them. You can switch them all off. And then the little sort of green arrows that are flowing through is the food stuff that the microbes are either attracted to the food or the mesh. There's also a data layer. And in the data layer, this allows, and this is something that I don't normally include in my work because I'm normally a little bit resistant to having something so obviously data-y. But when it was needed partly because it makes it easier for scientists to understand what's going on, and partly because I think when there's no physical work there, people often will stay longer in an artwork if there's something to kind of click around in. So here's where you can see how much data each individual fuel cell. So we've got a wall of 15 units, which the individual cell voltage down the side, and they generally stay the same around this kind of time. And then there's accumulated energy, so we can see how much useful energy is stored in the system. And then there's the stack power and the stack voltage. And then different things about the temperature and the humidity and the time. If you go to, and we also, what we're in the middle of building actually is this kind of simulation mode. So this is working, what you see now is working with the live data. So the things that are being triggered and the way that they're moving and acting is based on what's happening here and now. And sometimes when everything is stable, you get a very kind of consistent feel. And then when anything happens, like the feed rate goes up or something happens in the lab, the temperature changes, then you see more or less activity. But we built in the simulations so that people can accelerate what happens. So in the simulation mode, the yellow line just indicates it's going on, and then there'll be, at the moment there's only the addition of food, but you'll be able to heat the microbes up, and you'll be able to do another few things to change the system. And by having the simulation, it means that people can learn what affects the microbes, what generates more or less power. You can switch some of the data layers off. So that's the project. That's what I wanted to talk about. I mean, I find it really fascinating that these kind of, ideally, the long-term vision of this is that if this was built into your home using these kind of like ceramic bricks that contain the microbes, plumbed straight into the plumbing, so that all of the urine goes literally through the sort of wall of your house and then powers stuff. And then you have something like this built into the architecture, so you can see what's going on. And so the system is constantly monitored, and the way you monitor it is through something that looks, as kind of attractive, and there's like a living system, a living digital system in itself. So that was what we're kind of aiming to do. And yeah, that was all I was going to talk about. I have no idea how long that was. John T.
Hi, yeah, that was great. Thank you very much. It was sort of, you came to a very abrupt stop there.
Yeah,
So.
I told you it was completely, I didn't do my slides. I didn't really have a proper ending to it.
No, it's totally fine. So we, again, apologies for video stream problems. It actually looks like we may have caused issues elsewhere, but everything should be fine now, so everything's good. So we have a few questions, quite a few questions, in fact. So we'll try and spin through these quickly, if that's okay. So the first one is, are you going to build dune suits that recycle urine into power and other resources using your technology? So
You're going to build what suits?
Dune suits, as in from the story Dune. I'm assuming the answer is no.
No, but now you know. Now you've seeded the seed of an idea.
So someone asked, could this be used on a larger scale? I'm a boater, and a lot of us have composting toilets which collect pure urine, and we live off lead acid battery banks. It seems like a perfect combination.
Yeah. I think that is one of the key challenges at the moment, is to like scale it up. So there's still loads of optimization to do in those systems, like identifying exactly which bacteria are the most electroactive, because at the moment they're just all in there, and there's work being done at the moment to try and work out what is the best matrix, what is the best size, what is the best. And Yanis in Bristol has been working for I think nearly maybe a decade on this. So he's got to a certain point where they are generating, at least they can power a phone, so it's some useful energy. Whereas at the beginning it was really tiny trickles. So it's heading in the right direction. And I think with these sort of technologies, often get to a point and then it really accelerates and becomes something that is properly in a position to be sort of taken to market.
Excellent. So, Evan, you're muted if you've got something you're trying to say, or mime. Mime's okay too. You're still muted.
Yeah.
I'll ask another question while Evan fixes the Navy situation. Oh no,
sorry.
Back.
Go
ahead, Evan.
I have to push the button. Speaking of power, I was going to say, because Julie, you mentioned communities, and I wanted to follow up on the Dune suit because that sounded awesome. I mean, do you think does this have to work at scale, or is this really like a personal technology? It seems like you're saying maybe you need like a large reactor in order to get this to work.
Yeah, no, I don't know if it does need to be large. I mean, there's things like how you can embed more surface area into small shapes, and there's heaps of stuff to be done around that. At the moment, they've been 3D printing the cells using a sort of ceramic material because they want everything to be sustainable. But no, I think it could be a mixture. So we've been looking at proposals where we're embedding it with wastewater treatment, sort of through gardening and through reed beds and stuff like that, as a complementary suite of energy producing tools that sort of small circular, like a little circular economy of energy and waste. You could be cool. Yeah, I mean, I think there's huge potential for it to work on big scale, or just to do your own. I mean, I think that whoever was talking about having the compost toilet, this stuff is built by individuals.
That's the Dorkbot way.
Yeah. The most important question has been asked by Evil Midget, who says, and what happens to the smell?
Well, amazingly, so I didn't talk about the output. The urine goes, I mean, I have to say their lab is a bit smelly, but the urine goes in. And when the microbes have eaten all of the nutrients and stuff, what comes out is pretty much pure water. So there's no smell that comes out at the end. The microbes literally just take it out of the fluid.
They take the piss, is what you're saying.
They literally take the piss and give us power.
And one final question, because I think we've got a bit of time. Was from Karina, who says, is this anything like the concept of electric bricks, which I presume are the ones where they generate electricity when they're compressed?
I don't know about those. That sounds like it might be more like kinetic energy?
Kind of, yes, I suspect.
Yeah.
Anyway, that was all of our questions. So thank you very much, everyone. Thank you, Julie. That was excellent.
Yeah, thank you,
do you
Julie.
have any more questions?
I'm big into Hilbert curves, actually, which I don't know if people are into that. Someday maybe I'll do a Dorkbot talk on that. But just as ways of really filling up spaces with these sort of mathematical curves that pack an amazing amount of complex area into a very small shape. I was just wondering if you were looking at Hilbert curves or anything like that.
Yeah, I mean, I'm not. I think they're looking at that in the lab to work out how to Look, I think that we were talking at one point. He was talking about the folding. Is that the same thing?
Yeah, I think they're a bit like that. Probably people who know more about it will say yes. That's what I'll go with.
No, I imagine all of it.
Space filling curves, but yes, that's roughly correct.
The phrase.
Yeah, there we go. All right, on to our next talk then. And the last talk we have is by Air Giants, who make amazing inflatable robots, is the best way I can put this. They're an experience in real life. And I had the great privilege of climbing inside their giant amoeba a few years ago, which I very much enjoyed. Unfortunately, Richard, who is one of the leads on Air Giants, can't join us because he's evil. I would say he's evil, but he's not evil. He's a lovely man. Evil Midget, who asked a question, has unfortunately got stuck in my head. So no, Richard is ill this evening and can't join us. And I believe their third founder can't join us either. So today, this evening, the presentation is being given by Robert. And over to you, Robert. Or not.
Or just us again, yeah. I mean, we're kind of full of
here. Yeah. So it's fine. Oh, apparently, by the way, the stream is now fixed. We cause problems for other people. So well done, Dorkbot. We are a curse on other people. So
when it's back later, you'll know this is the point. It started working again.
Yes. But as we said earlier, there will be a recording of this. You can come back and watch later. But we're very sorry about that. It wasn't our fault. And Dorkbot will always break. We're still waiting for Robert, I believe. Oh, he's there. Hello.
Oh, yeah.
Oh, there we go.
I see. Sorry. Yeah. This. I'm part of Air Giants. We are a group of people who set out to make, well, basically giant inflatable robots that I need to share my slides, I guess. This? That one. Do we have a screen share now? Does this work?
Yes.
Great. What are we up to? We make giant inflatable robots. That's really a thing when you're in the same room, but it's best explained with a video. So this is Luma, our most recent inflatable creature. And Luma really is a snail, or we like to call it a snail. So it has a giant 3-meter long neck and a 4-meter tall arch at the back. And the thing that's really impressive is when you're in the same room as Luma and actually interacting with it, it just suddenly works on people. Everyone likes them. Children like them especially. They just instantly get that they're great and lovable and want to squeeze them. Yeah, that's pretty much it. So where this all really started out is Richard, who's not here today, started making giant inflatables a few years ago by starting with smaller experiments, this being the Trifid, one of them, which was luckily actually commissioned or partly financed by EMF Camp, which was the 2018 EMF Camp? So We are Emma Powell. She's a designer and puppet maker and a puppeteer who's part of the creative background behind all of this. Me, Robert Nixdorf, I'm a roboticist, software engineer, used to write software for a living, but everyone knows that gets boring after a while. And Richard, who also has lots of background in robotics and software engineering. And really, how we ended up in this position is about 10 years ago, Richard and Emma met at Dorkbot, where Richard was showing one of his creations, Sketchy, which was a drawing robot made out of a few servos, an Android app that took a picture, turned it into a vector graphic, and just sketched it. And from there on, this was Dorkbot in Bristol. And from there on, both of them have worked together on and off on various projects. So one of the things that they came up with was soft inflatables. This is actually some laminating foil between some paper between laminating foil. So when you inflate it with this small tube at the bottom right corner and blow up these pouches that form in the between the two paper layers, the whole thing contracts. And this is really something that has been going on as a field that's called soft robotics, but it really never got bigger than anything desktop sized. So most of these soft robotic experiments are either very, very small to go into human bodies or are about the size of an A4 paper. Anything bigger, really, no one has tried as far as we know. In this kind of principle, there are other big inflatable robots, but at way higher pressures. So, well, we all are people who like to make installations and have done a few. So for me, my kind of moment where I got into, actually being creative and I could do something in arts was when I got involved with the CCC Congress. So for about 3 years, I was, because it was very easy, because it was in Hamburg, and I am from Hamburg, ran a class, the pneumatic tube system, which was in the first year, something like 2 kilometers of yellow drainage pipe running all through the Congress Center, where you could hook up shop vacs and send small capsules. And then the next year, no one really wanted to run it. So I ended up running this and organizing it for 3 years. And that was great fun and was really an eye-opener too. If you give people something that they can tinker with and kind of touch, and that's obvious how to engage with it, or more, it's allowed to engage with it, people start doing that and they love it. Whereas Richard and Emma both, that's my background. Richard and Emma more learned each other or worked together on a project which was a small robot they made with a local Bristol company, which was called We the Robots, which was, I think, it to me, it always sounds as there was work for 6 months, but they did it in 6 weeks, and they made an emotionally effective robot that interacts with people. And basically, the idea behind it was to make a robot, prototype it quickly, find out what parts of it people like, what works, what lets people just be annoyed by it or ignore it, then puppeteer it from a distance, record the best behaviors that work, and then replay them. And that was where both of them learned quite a lot about how to make emotionally effective, lovable robots. So then a few years later, this is an event very similar to Dorkbot, which was MOG, which was an event in Bristol where a group of 8 people met over a few weeks to make an installation. And Richard had, in the meantime, developed more inflatable, like this size scale installations. So this one is his tentacle. So it has, I think, 3 bellow joints, 4 bellow joints, and some simple distance sensors. So it basically plays catch with you. And it just works. People either get it and want to hug it, or that's weird, I'm not going to interact it. But most people just go, okay, that's fine, it's safe, I can interact with that. After that, EMF camp was up. So what was obvious was there has to be giant inflatables at EMF camp. So Richard made the Trifid, which we saw earlier in the first video, which is here in the right-hand corner, and the Anemone, which is 3 meters in diameter, and it varies the pressure inside a little bit. So the blobs at the side come out and go back in, depending on the air pressure. And it is really a lovely experience to be inside of one. I can confirm that. I recommend that to anyone, but it's just as if you are in a different world. So after we did that, and I got into, basically at EMF camp, I decided robots is the thing to do. I'm going to move to Bristol and going to do robots. And now there's robots everywhere. This room is full of robots. I can't step anywhere without finding one. Half a year passed and we started a company. So we applied for a grant from something called the Southwest Creative Technology Network, and specifically their Automation Prototype Fund, which is part of Research England's Connecting Capabilities Fund to support university collaboration. And that was, there were quite a lot of applicants. We had to go to a shortlisting interview and we got the grant. So this was, we very much had an idea sketched out, but it was an R&D grant. So then in January, we dug in and started prototyping and experimenting, and we built lots and lots of prototypes. There's a very high number and months passed where we made one prototype after the next, finding out lots of methods for making inflatable actuators. In all of that, COVID hit, so the part we could do user interaction and actually take our things out into the world, which was set to be in April, didn't happen. So we spent most of our time taking business advice and workshops from the Southwest Creative Technology Network, which was highly helpful. And being very fortunate, because all big venues were shut, we got the opportunity to use a very big workspace in an old mansion house. So we started sewing for about 3 weeks, 4 weeks, and made Luma based on all our experience that we gathered throughout the year. And in October, we showed off the Luma for a showcase, which was, again, in form of videos, basically the video you saw at the beginning. So how do they work? There's no hard structure in any of our robots. The only thing that's very hard are the valves. They're about 60 centimeters in diameter, and it's a bit of hard plastic. Everything else is fabric, lots of seams, and there's some DMX lights at the bottom, which give it some weight, and you add weight at the sides. There's no motors or pull cords like winches in them. It's all bags of air that pull. We run them off of 2 big bouncy castle blowers. They're fairly energy efficient. You can just buy them. They make enough air. The really tricky part, though, is making geometries of actuators that do the actuation that you want or do the thing that you want. Very often, even during prototyping, we would sit there, draw something, go, this is going to do this. It's going to bend like this, and it's going to be amazing. But then you try it, you sew it up. Sometimes it's literally an experiment that takes 10 minutes. You put air in it, and it does something completely different. And that's a very hard part of the work that we found. All the creatures don't really need to be airtight. They're all just simple seams. There's no special sealing the seams. You can have quite big holes in them. They still work. It's quite astonishing. But what we found, you need quite a big workshop just to run them and to test them. And a very big table is handy to lay all your fabric out, draw it, and cut it out. Valves. So these are some valves that make our robots go. This first one here up in the upper left corner is, I'd call it a drum valve, which runs the tentacle. So it has a servo in the middle, a model servo, and this drum at the bottom rotates with that servo. So you can switch between 2 different stiff, and that goes into a tube. So that's quite rigid. But if you want to have fabric only valves, we made some other prototypes. This upper right one is a flap with a push rod. That's quite hard to actuate because you can't just have a servo. You kind of need a rack and pinion. Then we went to some flaps, basically. So this is a servo on a very long lever to swap over this flap from the net to the side where there's no net. Don't do that. It breaks servos. They don't like that, having that long levers, and if it catches anywhere, it just gets stuck. So the valve that seems to work best is sort of this griddle style turning valve, and that's what is driving our snail. All those servos need to be controlled somehow. So we made a set of nodes that run all of our chambers. And this is very much put together from bits. You have a blue pill here in the middle. The lovely thing about that is it's quite fast, it's cheap. This PCB at the bottom was made by me, and you can add a pressure sensor and an IMU to do sensing and work out where your robot is, really. The lovely thing about the blue pills is they can do CAN bus. CAN bus is great because when you make a 10-meter long installation, your wires suddenly get quite long, and something like an I2C bus doesn't work anymore. So you run into lots of issues, and CAN bus is readily available and all the components are cheap these days because it's what makes most modern cars go. Yeah, those nodes all wire up on industrial wires with nice watertight connectors. And I think there's something like 20 nodes in the full setup. So 24 nodes, 4 valves each. That's a bit too many, but roughly, I think there's something like 50 valves in the whole thing if you add the eyes. Controllers. We started with some simple slider controllers, like a mixing desk. Then found out we need something more fancy with some joysticks and some sliders. All of this is very not fancy. It's all based on the same hardware, really. But recently, we got slightly more fancy. So this is our next controller with 2 joysticks, a Raspberry Pi, and a display. Lights, standard normal DMX lights, go in the base, light everything up. It's very simple. And the best thing is, most of this, in terms of software, comes from standard robotic software. So this controller, for example, runs ROS, which is Robot Operating System, which is a set of open source software and scripts for running robots. So you get lots of diagnostics and message exchanges for free. That's really not free. That means it's painfully worked up to and working out the documentation. And UAVCAN and Drone Code, who make software frameworks for running large buses on drones that are somewhat reliable. And that's really plumbed together bits. So why are our robots great? They're huge, they light up, they're interactive, they're squishy. People, adults of all, kids of all ages like to stick their heads in them. They just get that they're safe, they want to hug them. At EMF camp, there was a lady who was very, very excited about the tugging it for half the night. It was fun. But the best thing about it is they're very light and very easy to transport. Luma, our 10-meter long, 4-meter high soft robot, fits in this tiny bag, plus 2 blowers and some weights. But that's it. You can put it in the back of a car. You can just take it from A to B. What's next for us? We are currently looking for commissions for events for science centers who would like a giant inflatable for their event. That's quite difficult at the moment because of COVID and everyone's uncertain when the next event will be. We're looking for collaborators for said events, or if you have a great idea about how to make control a lot better, get in touch. There's lots and lots more work to do on audience sensing and motion control. So my plan is to take all those sensors and make full robot control. So you get data from the IMU and have the robot know about its position and be able to move to position. But we've ran out of time. That didn't happen yet. Yeah. Do you have questions, suggestions, or would like to collaborate with us? Get in touch. there's more information on our website, airgiants.co.uk. Find us on social media and send us mail.
Cool. Ali, can you move to us, please?
Mm-hmm.
Ooh.
Great. Thanks, Robert. We have Janti in the darkness there. There he
I'm
is.
here. Sorry. So we have a bunch of questions. I think some of them you've already answered. But the first one is, did you set out to create a complete creature like Luma, or play around with concepts first and then decide on a full design later?
We started, so we knew at the beginning, we knew that tentacly type things were possible, and it was quite obvious. Everything we spiraled around ended up being, it has 1, 2, 3, 5, 10, 300 tentacles. So we deliberately said, we're not going to do that. We're going to try and make one actuator after the next that can do different things. So we have a catalog of, I don't even know how many, quite a lot of different principles. If you have 2, 3, 4 chambers of different pressures and move the pressures in them, how they actuate. We decided through quite a long selection process of things that we think we could make or that we would like to make, what it would be.
Cool. So next up was actually it's been voted up as the highest question. Have you done any that float on water, like a whale that could nip around an outdoor Lido?
It might come as a surprise that if you take a bag of fabric and fill it with air, it's almost as light as air, and it definitely is lighter than water, so they float. The only problem you have is finding an air supply that floats with it and running enough power to it so they float. So yes, they do float. We've not tried that yet, but if you have an idea, I would be excited to try that.
I have some lakes available in 2022.
Well,
that's interesting because someone mentioned Other Lab as a comment.
Yes.
And I was looking at their video. Yeah, they see, but that seems like a very different system, right?
So the Other Lab robots are basically made from what I can see on their videos. There's one that's, I think, like an elephant. It has 4 legs. They're made out of PVC tarpaulin, I think, glued together. And by the looks of it, their pressures are way higher. So there's just one compressor hose going in, or multiple. I'm not sure anymore. It has been a long time since I've seen that video. But it seems they went very quiet some years ago. There's not much coming from them. That runs at a lot higher pressure. Our things run at bouncy castle pressures, which is not compressor powers, not multiple bar. I think it's something like 200 millibar or something. But I'm not sure about that.
So I'll go for a couple more questions because we're running a little bit late. But does designing the actuators have much in common with kites and balloons?
I mean, it has a lot in common with designing the actuators. Designing the actuators doesn't really have much in common with kites or balloons, I think. So balloons are just holes around a volume of air, and then you have to manage tension in the fabric somehow that you stay in shape. Whereas we don't run everything at constant pressure all the time. Certain bits, of course, like the body, are constantly inflated. But then other bits have varying pressures, and then they collapse. So you run into other trouble there.
And of course, balloons are made by magicians and clowns, and robots are made by scientists. So that's a huge difference right there.
Well, I live in Bristol, so I was thinking hot air balloons. Cameron Balloons is just a few miles that way. So they make very big, just round shapes. I mean, they can do shaped inflatables, but I think that's quite different. But many techniques from kite making and balloon making go into this. Like, you need to know how to sew, you need to know how to do a tidy seam, and how to manage surface tension or tension in the fabric with lots of different bits. Like in kites, you can have webbing or strings. Yeah. The only difference is there's no rods in any of our things.
So
But
final question. Sorry, go ahead, Ian.
I was going to say, so you're saying that a hot air tentacle balloon is not quite possible. Is that what you're saying? Or is that possible? Is that in the cards sometime?
I mean, I would be up for that. I think the biggest trouble with hot air balloons, as I understand, is that really the standard hot air balloon shape is sort of optimal, where you have most of your hot air lifting the thing. If you add bits onto it, like there are hot air balloons with cat ears and other bits, then those don't get filled with hot air, and then they're basically weight. You have to carry all that air with you.
They're like cold air pockets.
Yeah, I would absolutely be up for making actuated hot air balloons.
What I'm hearing here is that you need to make a really big hot air balloon with tentacles on it. So that sounds feasible to me. So
yeah.
So one final question, and then we should move on. How noisy are they? And you've already answered this, but do they use bouncy castle style blowers?
Yes, they do use bouncy castle style blowers. That's something that's sort of unavoidable. You can manage it by, if you want to run it inside of a building, you can run tubes to it and put the bouncy castle blowers outside. So it's a lot quieter in your room. Once you get to the outside and run them in a field between deer, and there's other music around it, then the noise from the blowers is more or less unhearable. As soon as there's enough people and enough going on, you don't hear it anymore.
Can I ask one tiny follow-up, which is,
sure.
I mean, it sounds fascinating, all the research you guys have been doing. I mean, are you going to try and publish this at all in some form in the future, or what do you think?
I mean, I think there's lots of it that just by looking at it, you can work out yourself. But some of it is definitely our secret sauce that we would like to keep for us for a little bit, so we can make more of these, because our intention is actually to sell them. And there's nothing out there that we have seen that is just like it.
It looks very unique. And you do have to afford the tentacle balloon. I mean, that's a big future endeavor. So yeah, that's going to take some money.
I can only hope that at some point you manage to bring one of these due to an actual Dorkbot in London inside the Limehouse Town Hall, and we have a giant inflatable snail with us. That's all I really want.
Anytime when it's feasible.
Thank you very much. In which case,
thank you.
I believe we do have one more performer, not on the lineup. So Evan, would you like to take it away?
Yeah. Maybe.
So, Emma, are you actually there?
Oh, you are, but we can't hear you.
Maybe not.
Oh. Maybe having technical difficulties?
Just a moment. Sorry. I have to apparently reset all my audio again. So
well, that's also classic Dorkbot. I mean, what would it be without rebooting?
This is into like what the 6th hour of the tech setup now.
I actually don't know if anyone can hear Emma talking to us right now. So Emma is otherwise known as Deerful. Has performed at Dorkbot before, about 4 years ago, I believe. And she does wonderful live coding and live vocals at the same time. And this has been a full day, in fact, 2 days of Emma trying to get her live streaming setup working with what we're doing today. And it ran right up until 6 p.m. today. So we're hoping this is going to work. Emma was supposed to perform at Christmas last year and it didn't work out. So it's this Christmas instead. So this may not work If it doesn't, that's okay.
Oh
Don't.
my God, I can't.
If it doesn't, we'll just do some beatboxing. I mean,
Oh
that's
God,
that's how it's
don't
going to
know.
have to end.
I don't know why it's not working. Oh my God.
Uh-oh. We could also do another 6 hours of just technical setup. I mean, I'm sure people would find that fascinating as well.
Yeah. And Evan, if there's any beatboxing, it's just you. I'm not involved in that. So.
I'm gonna pass today. I'm gonna say it's because my throat's hurting me a bit. That's all.
Is this?
That's my excuse.
Can you hear me?
We can hear you perfectly.
Okay. Right.
Can't see your screen yet, though.
I haven't shared it yet. That's phase 2.
Mm.
To be clear, I've never done a live stream before, and it's been like 18 months since I last played live. So.
Oh wow.
There's a reason that I made them keep it a secret.
It's like one of those secret small club gigs where you don't know who's going to show up and they're testing out some new material, like, you know,
Exactly.
Beyonce going acoustic, that kind of thing.
Exactly like Beyonce going acoustic, except like imagine Beyonce going acoustic crossed with like a bin fire. And oh no,
That's
I've
very
just shared the
2020.
wrong. I think I just shared the wrong.
No, you've shared the
We've
right
got
thing.
code.
That's fine.
I think
Yes.
no, I think it's the wrong session. Hang on.
It's the
Oh no,
wrong
it's not.
code.
No, it's not.
It's the right code.
It's the right.
There's no such thing
session.
as the wrong code.
Okay.
Spoken like someone who hasn't heard me play from the wrong code yet. Okay. Now I just have to enable my vocal effects. Okay, fingers crossed. Thanks for having
Yay.
me.
Good luck.
Am I reverbed?
Yes.
Okay.
We can't see your screen yet, though.
I'm sharing it. Can you?
There we go. We're good. Looks wonderful.
You can see it.
Yeah, it's all
Perfect. Yeah.
Sorry. Sorry, I'm just trying to make it so that I can see my screen. This is going well so far, isn't it?
It's like one of my teaching sessions, actually.
If I had a guitar, I would just be endlessly tuning it right now, just to make everyone feel really uncomfortable. Anyway, oh my god, it just crashed.
Oh no. No. Will it take a second to reboot?
Yes, it will. Sorry, I'm just turning my reverb off while it reboots. My live coaching language just crashed.
This wouldn't be Dorkbot if at least one of the performances didn't take 15 minutes to get going. It's just how it works.
This is why we need the bar.
Happy
I mean,
to
Jonty,
watch.
you have the bar. I mean, I feel
I
like.
came prepared. Like, you know, it's.
I mean, yeah, I should grab a beer. Okay, this is time. If now's a good beer time, let's say, you know, in spirit, you can go to the Dorkbot bar.
8 beers.
The bar.
Is there a black window that's just been shared?
Yes.
Okay, super.
Mm-hmm.
There we go.
Okay, I believe it might be. Here we go. Over to you again.
Mm-hmm.
This set is very specifically set up to leave no room for applause because at Algaraves people get freaked out if you make them applaud. I learned this the hard way.
Yay!
None of you could see the terminal window for Ixie, which was gradually freaking out more and more as the last song continued. So we made it to the end.
No crash. I mean, is
No
that
crash.
a proper live coding performance?
It was really close though. It was really close.
It was wonderful, and the feedback from people in Slack and Twitter and everything is that was a wonderful gig.
Oh, thanks.
Thank you
I
so
couldn't
much.
see any of the feedback.
You
Thanks
get
for
to
having
read it
me.
later.
That was fun.
It was all good. It was very nice feedback. They were trying to egg me on to clap during the performance, but I didn't want to distract you.
It was so nice to end that way.
Yeah.
And,
That was fun.
I'm so glad that all of the hassle you had and the problems, that it was worthwhile.
It was worth it. We did it.
So much.
Yeah.
Thank you for
What a
having
wonderful
me.
end. Yeah. And 2020 is almost over. It's a perfect end to it. We've had a Dorkbot now. I feel like this is success in so many ways.
So we had a few questions about the set though, so I feel like
Oh
we should run
gosh.
through them.
Oh my gosh. I was not prepared. Okay.
I wouldn't worry about it. They're not complicated questions.
Okay.
One of them was, do you ever find yourself reading the lyric lines by accident?
Good question.
I definitely read the wrong line in one of the songs just now. in the Chainsmokers cover, I definitely made a mistake there. So I mean, it's only a matter of time, really, isn't it? Hang on, I'm just going to change back to my normal mic so that I'm not hearing myself in my own headphones. Just a moment. Oh,
can we do a follow-up to that too, which is, do you ever actually read the code lines instead of lyrics?
wait, was that not what was just asked?
I think he's asking
Am I
for
back?
lyrics.
Can you hear me? Oh no.
We can hear you. I'm not sure if anyone else can hear you.
Oh no.
We could.
You can hear me, but my webcam's not on. Hold on. Now? Now? Can you hear me now?
Yes.
Yes.
And
Okay,
you're
great.
still not on screen though, so Alfie.
Oh, really?
You... There we go.
Okay,
Yeah, that's
there
fine.
we go.
Alfie's put you.
There we are.
Yes, no. It was more about reading the lines rather than singing out what you knew already, I believe. But,
Oh, good question, actually. I mean, this time, actually, definitely I was reading the lines because I haven't played a gig in like 18 months because all I do is try and finish my PhD. But yes. So yes, actually, this time I was absolutely doing that, 100%. And no shame. I mean, a little bit of shame, but not a lot. But yeah, I mean, it's only a matter of time before I accidentally read one of my stage directions to myself, right?
Or never line of code where you just go accidentally 1 1 1 2 2.
Yes.
Yes.
Yeah. I
mean, next question
sorry,
was.
Ixie is continuing to crash in the background. Let me just address it before it.
Well, that's the software, right? That is the next question. What is the software?
So the software. Is my screen share still on? Okay, right. Okay, brilliant. The software is it's a language, but also like a sort of standalone program called Ixielang, which is very, very old. It is made by Thor Magnusson, who was at Sussex University. I don't know if he still is, and is now doing like AI music stuff. He's way in the future, and I'm still using his like 11-year-old piece of live coding software. If you look on my website, which is not my music website, my like work website, which is emmawinston.me, I have a blog post about how to get it working on a computer that is not 11 years old. Whether it still works, I have no idea. I haven't tried to like update my Mac because I'm afraid it will stop working. So no promises, but it is worth a go. A friend and I tried to remake it in the form of a program that runs on top of Atom. The IDE, is Atom an IDE? My goodness, I've been in humanities land for too long. Which is called, oh my god, I really hope Guy isn't watching because I've forgotten the name of the of the language that he mostly rebuilt. I think it's Atomics, but with 2 I's. Oh, and an X. So ATOMIIX.
That sounds right.
Google that. It exists on GitHub. I'm not sure if it has all the features that IXI does. At some point, I need to try and move my live set into it. So I'll be able to tell you then if it does. But if not, then please try it and tell me if it if it does. So yeah, various ways to accomplish that. But
I think also it does run inside Sonic Pi these days.
Oh, does it?
I'm 99% sure that there is IXI-lang inside Sonic Pi.
So I know at one point.
Maybe someone can say in the chat.
I know at one point it was the kind of the syntax that like the little strings of numbers between square brackets thing, which is essentially like notation. Those are like degrees of whatever scale is set, and the kind of white space between them is it like denotes time, and I think that has been in Sonic Pi for. I don't know, it's probably donkey's years at this point, actually. I don't know. But I wasn't aware that Sam had added the rest of the language, which he might well have done. I have no idea.
Oh, that's a good point. I mean, this gets down to language conservation. Which is not always an easy thing.
I rely a lot. I mean, actually not so much in that set. But I was relying a lot on, it has this snapshot function where you can essentially save like a snapshot of all of the actively playing parts to memory, and then you can recall that kind of instantaneously, which allows you to switch kind of groups of instruments all at once, because otherwise you have to select it line by line, which is the thing that we changed in Atomics. You can just select whole blocks of code and then run it, I think.
So there's a lot of nuance in this that doesn't exist, maybe in like a reinterpretation.
I don't know if it might have been added into Sonic Pi, because at one point I was begging him to do it, and I can't remember if it was something that was on his roadmap or not, to be honest. It's God, I'm so sorry. I'm being an absolutely terrible advocate for live coding. It's been so long since I've actually done it.
Well, that follows on to the next question, in fact, which was, how did you get started doing music like this?
Oh my gosh, great question. Really great question. Goodness me. Oh, do you know what? Actually, I'm doing a PhD, trying to finish a PhD in music at Goldsmiths at the moment, and it's nothing to do with any of this. Like, I study like ukulele players and like the subculture surrounding the ukulele, like the sort of third wave resurgence of it in the 21st century. And it's like a theoretical PhD, and I was really jealous of everybody in my cohort who was doing practice-based stuff, and I was trying to go along to as many like events that my funding consortium were putting on that were for practice-based PhD students as possible. And I went to a thing at Sussex University where one of the sessions was Thor teaching how to use IXI, and I kind of fell in love with it straight away. It's so different from every other live coding language I've used. I think the reason I like it is that it's a bit more like kind of traditional notation, but also more accessible than traditional notation in that it's kind of numerical, like as the number goes up, the sound also goes up. And I instantly really liked it, installed it on my computer, forgot about it for like 2 years, and then found it when I was procrastinating, wrote a song in it straight away, like as soon as I had realized I had it installed on my computer. In like 45 minutes, I wrote Bloom, which was the second song that I played tonight. And I was going to say the rest is history, but the rest is not really history. The history is that I wrote an album very quickly and released it in September of 2018, and then played a bunch of algoraves with people who make music that's very, very different from and much cooler than me. And I haven't done anything in it in ages, but this has kind of reawakened my interest in it, really. It's every time I actually kind of open it, get my hands on it, I'm like, I want to make more things with this. So, highly recommended.
It's the beauty of procrastination, especially with a
Yeah.
PhD.
Yeah.
I wonder how many great projects come from procrastinating a PhD.
Literally all of mine. The main thing that my
That's why you do
PhD
it.
has given me has been, I shouldn't say the main thing, just in case anyone who might want to hire me as an academic is here. Everything I've achieved when I should have been writing my PhD. That's not true.
So the next question was, are you going to put the Chainsmokers track on your Spotify?
Do you know, if the person who asked that knows what the kind of copyright issues of doing that are, then please get in touch with me, because the reason that that's not on my Spotify, and also the reason that the thing that I'm best known for on the internet is doing a really normie cover of an incredibly experimental song by the producer Sophie, and I get probably one email every 2 weeks asking me if I will put that cover on Spotify, and I've been avoiding doing that as well because I have no idea how to put covers on Spotify. If anybody knows, please send me an email, tell me how to do it, because I just don't know. And
So
that would
our
be
video
great.
our video engineer Alfie has just said that they know exactly what you need to do and they'll be in touch. So
Oh my gosh.
so maybe that's going to happen. Yeah.
There you go. Dorkbot serendipity.
Amazing.
There you go.
They've been my savior so many times today.
And we have one final question, which is, did you come to coding or music first, and how much does the coding style influence your music?
Music, 100%. I mean, I've been making music in some form since I was extremely small, and I was going to say I didn't start coding until really late, but that's not true. I spent sort of between basically my whole every lunchtime at secondary school was spent in the IT room building terrible teenage girl websites that were really heavy on elaborate Photoshop brushes and tiny text, the smallest text, and tiny scroll bars that were you used to be able to customize scroll bars. Terrible for accessibility.
Oh yeah.
But great for teenage girl aesthetic. Can't do that anymore. But music first. But I was big on. I say I was big on HTML, CSS. I still am quite big on HTML, CSS, really. But yeah, I've kind of somehow ended up with coding as my hobby and music in some form. Well, researching music at the moment is my day job. Not quite sure how that happened, but I was doing music first, and I am probably a more competent musician than I am a coder. But in terms of how it influences the sound, I mean, it's a huge influence. I think that the album that I made with Ixie has a very different sound to it from my preceding album, which was made with hardware synths. And I mean, it's very limited. It's a very, very limited language, and there are certain things that don't really suit it. And I think the kind of there's sort of a percussion style that runs throughout that album that is sort of made up of sort of almost found sound type noises, which are very sort of short and clipped, and it doesn't cope with percussive sustain very well, and it lends itself very well to kind of almost sort of ASMR type clicks and dings, and also I guess structurally there's a couple of songs on there that are sort of verse chorus, and I guess the last two songs that I did in that set were kind of verse chorus, but it's not really built for that. You sort of have to use either the snapshot function, or you have to scroll through very, very fast and execute multiple lines as quickly as possible and hope that no one notices that there's overlap between them. But what it really lends itself to well is kind of looping and shifting sort of line by line between loops. And so a lot of the songs on that album, even though they're kind of nominally verse chorus, they're sort of based on one sort of minimal repetitive chord sequence. And also something it does really well is weird time signatures. Bloom is in I think I sat down and I worked out what time signature it was in, and it's something ridiculous. It's like 13/8 or 15/8 or something that shouldn't be, which is because I was trying to write something in 4/4 and I accidentally left out a white space from one of the first two percussive loops, and it changed the time signature into something really interesting, and that kind of became the sort of root of the entire song. And so it's very sort of conducive to happy accidents. And I think my songs sound completely different when I'm not using it. I think my songwriting in it is probably more interesting than it is when I don't have a really kind of capricious computer making happy accidents for me.
When you have nice constraints, yeah.
I love constraints. I love a constraint.
Especially electronic music, they can be so helpful sometimes. Yeah.
Well, because otherwise, I mean, where are you going to stop?
Exactly.
Who's going to stop you if not the computer?
Well, I think
Speaking
also,
of that,
talking of stopping, in fact.
I was going to say, thanks for listening to Song Exploder.
But that's fine. This is Dorkbot, and we always run late. So that was wonderful. Thank you very much, Emma. It was
Thank
really
you.
great.
Thank you.
Thanks for having me.
Yeah.
Brilliant.
In which case, I guess it's time for us to say goodbye. We have everyone on screen at once. So look at that.
Yay. We can thank them all.
Not prepared for that. Nobody was ready for that.
That's it. You're on camera again, guys. Hey.
So thank you very much for your talks. That was wonderful. And we will be back next year, I believe, at some point. For Dorkbot 100. And,
it was so great to see you all. And so great to see everybody in the chat. Unfortunately, you're seeing us, but we're not exactly seeing you. But we have your little icons in the chat. So there you go. Sending out Dorkbot love to your icons.
Yeah, thank you for joining us. And we'll see you next year. Have a lovely Christmas.
Oh, and thanks to Alfie, Jaunty, Henry, who did most of the organization for this. Thanks to everyone on the committee, and Julie and all the rest of the Overdorks for their all their support, and everyone else. Thanks to everybody.
Thank you so much, everyone, and we'll see you again. Hopefully not online, but we've had enough people say that they've loved the online streams that maybe we need to try and do this from the town hall as well. So you never know, we might be back.
Next time we'll be riding a tentacle, filled up with air with like video cameras. It'll be fantastic.
Just Evan's doing that.
Just with a big crash helmet.
Right,
gang.
Good night, everyone. Thank you very much. Have a lovely Christmas. Stay safe.
Take care. Okay, bye, gang.
Bye.